Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. Came across this at phys.org. Yes, photon entanglement could explain the rapid brain signals behind consciousness. This should be very, very interesting indeed. Yes, and as usual, I'll leave the link to the main article below the video so you can pop in, check out the embedded links, go for a bit of a deeper dive if you want. Makes for a very, very interesting read, believe me. Yes, my camera's not working today for some reason, but that's all right. I'll fix it tomorrow. It's probably a good idea to get a break from my magnificent features. Yes, don't get people to get too excited, do we? All right, so understanding the nature of consciousness is one of the hardest problems in science. Some scientists have suggested that quantum mechanics, and in particular quantum entanglement, is the key to unraveling the phenomenon. Now, a research group in China has shown that many entangled photons can be generated inside the myelin sheath that covers nerve fibers. It could explain the rapid communication between neurons, which so far has been thought to be below the speed of sound. Too slow to explain how the neural synchronization occurs. The paper is published in the journal Physical Review E. Yeah, that's always fascinated me. Rapid communications between neurons and just in general. I mean, I don't even, it's subconscious, obviously, thinking about, for argument's sake, moving your hand. But then all of a sudden, it just, there it is. Like, I don't understand. It's quite fascinating. Yeah. Absolutely blows me away. As I said, any real scientists out there, because I'm not a scientist myself, feel free to weigh in because it's absolutely incredible. If the power of evolution was looking for handy action over a distance, quantum entanglement would be an ideal candidate for this role, said Yongkong Chen in a statement to phys.org. Chen is a professor at the Shanghai Center for Quantitative Life Sciences and Physics department at Shanghai University. The brain communicates within itself by firing electrical signals called synapses between neurons, which are the main components of nervous tissue. It is the synchronized activity of millions of neurons that consciousness, among the other brain business, relies on. But the way this precise synchronization takes place is unknown. Yeah, it's pretty quick, isn't it? That synchronization. It's almost bordering on precognition. It's absolutely incredible. Connections between neurons are called axons, long structures akin to electrical wires, and covering them is a coating sheath made of myelin, while white tissue made of lipids. Now, comprised up to hundreds of layers, myelin insulates axons as well as shaping them and delivering them to the axons. In actuality, a series of such sheaths stretches across the length of the axon. The myelin sheath is typically about 100 microns long with 1 to 2 micron gaps between them. Recent evidence suggests myelin also plays an important role in promoting synchronization between neurons. That's absolutely fascinating, isn't it? Yeah, very interesting indeed. But the speed at which signals propagate along the axons is below the speed of sound, sometimes much below, too slow to create millions of neuron synchronizations are the basis for the amazing things the brain can do. To remedy this, Chen and his colleagues investigated if there could be entangled photons within this axon myelin system that could, through the magic of quantum entanglement, communicate instantly across the involved distances. A tricarboxylic acid cycle releases energy stored in nutrients with a cascade of infrared photons released during the cycling process. These photons couple to vibrations from carbon-hydrogen bonds in lipid molecules and excite them to a higher vibrational energy state. As the bond then transitions to a lower vibrational energy state, it releases a cascade of photons. Interesting. Absolutely fascinating. The Chinese group applied cavity quantum electrohydrodynamics to a perfect cylinder surrounded by the myelin, making a reasonable assumption that the outer wall of the myelin sheath is perfectly cylindrical conducting wall. Now, using quantum mechanical techniques, they quantized the electromagnetic fields and the electrical field inside the cavity, as well as the protons, that is, treated them as quantum objects. And then with simplifying assumptions, solved the resulting equations. Doing so gave the wave function for this system of the two protons interacting with the matter inside the cavity. They then calculated the photon's degree of entanglement by determining its quantum entropy, a measure of disorder using an extension of classical entropy developed by the science polymath John von Neumann. We showed that the two photons can indeed have a higher rate of being entangled under occasions. Oh, okay, said Chen in his statement. So the speeds here we were talking about were lower than the speed of sound, which is not enough for our brain to do what it's done. So this is really interesting. So they were able to figure out that at certain times, certain functions in the brain probably run a lot faster than the speed of sound. Yeah, there is a way of getting to these things and getting around these things. I was saying it was something similar like traveling faster than the speed of light, and nobody said we could do it. I'm sure there's a way around it, because if nature hadn't to come up with this idea, humans wouldn't certainly be as, shall we say, as far ahead as we are. It's quite fascinating. Yeah, we showed the two photons can indeed have a higher rate of being entangled under occasions. So the conducting wall limits the electromagnetic wave modes that can exist inside the cylinder, making the cylinder an electromagnetic cavity that keeps most of its energy within it. Okay. These modes are different from the continuous electromagnetic waves or light that exist in free space. It is these discrete modes that result in the frequent production of highly entangled photons within the myelin cavity, whose rate of production can be significantly enhanced compared to two untangled photons. Now, entanglement means the two photon state is not a classical combination of two photon states. Instead, measuring or interacting with one of the photons instantly affects the same property of the second photon, no matter how far it is away. Entanglement has been demonstrated for a system whose members are over 1,000 kilometers apart. Nothing like it exists in classical physics. It is purely a quantum phenomenon. Here, the entanglement would raise the possibility of much faster signaling along the sections of myelin that encase segments of the axon's length. There we go. Yeah, faster signaling. That's very interesting. Yeah. Because obviously the faster signaling is what gives the human brain the power to do the things that it does. One possibility the authors write is that the entanglement of I love how the brain can switch it on and off, though. It can be chugging along and then go into this turbo mode. I'm guessing that's right. One possibility the authors write is that the entanglement of photons could transform into entanglement along potassium ion channels in the neutron. If so, opening and closing of one channel may affect the performance of another somewhere else. Chen told Phys.org that their result is a combination of two phenomena that exist but are still largely mysterious: consciousness, let alone quantum consciousness, and quantum entanglement. We won't say there's a direct connection at this early stage. Our primary goal to identify possible mechanisms of neural synchronization, which affects numerous biological processes. Through this work, we hope to gain a better understanding. That's really interesting. There's got to be a connection there somewhere. There has to be a connection between the two phenomena, which is consciousness and quantum entanglement. I honestly think there is, and I think that this sort of research can be applied to many, many things. Because to say this is why I think people who have highly tuned instincts are, how can I put it? It borders almost on precognition, and I think what it is that they're this bit down here. As I say, I'm not a scientist. I'm trying to understand it in my head. Quantum entanglement, right, could be operating at a much higher level than the average person. So not only are that used to be called quick thinking, but you can imagine having reflexes that are absolutely sharp as whatever. Sharper than the sharpest thing that's ever been so sharp, and sharper than something that's really, really sharp, and won the award for being the sharpest thing ever. The way your mind works is operates on a whole nother level, and that just fascinates me. And it's information and stories like this that just blow me away. It's fascinating. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video, because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
I'll be back.